Hello, everyone. I'm James Joe, the teaching director of the iLab. I got the CCNA certificate in the full direction of routing and switching, service provider, voice and data center, and got the certificate of JNCIP-SP and HCIS. My English not good, not very good, but I hope to share my knowledge and experience to everyone. For everyone, if you have any question during the lecture, you are welcome to ask a question and discuss at any time. Learn knowledge, pass the exam and get the CCNA certificate. If you want, contact us. You can add my Facebook. Here is my Facebook. James Joe. You can add me, and you can find ilab.network. Yeah, iLab official page. You can find. You can add this Facebook. Got the news. Or we have English website, ilab.network. If you want know us, you can access this website better. Leave your name, WhatsApp, and email to contact us. Okay, let's start the course. Yeah, let's start the course. Okay, OSPF courses are divided into basic courses and advanced courses. This is outline of the basic course. First, it introduce the overview of OSPF. The following is the framework of OSPF. All of them are framework of OSPF. The basic course are based on framework. Everyone should be familiar with the basic framework. It's very important. Okay, let's start. OSPF is a link state protocol. RIP and EIGRP are distance vector protocol. Distance vector protocol. The distance vector protocol mainly divided into two parts. One is distance. Distance means how far the destination is from me. The other one is vector. From which direction can I reach my destination? Vector. The router learns the routes from the neighbor and compare it, then put best routes into the routing table. This is distance vector protocol. The link state protocol learns the tuples from the neighbors. Triple tuples from the neighbors. One is which neighbor I have. The second is which links I have, and the distance to the neighbor. One is I have how many neighbors. The second is how many links I have. The third is the The third is distance to the neighbors. This information not routes. It's LSA. The router send both sides, right? And put this LSA into the database LSDB. Run SPF algorithm. Calculate shortest path tree. Then put calculated best route into the routing table. This is link state protocol. Okay, go on. The link state protocol, like a sunflower style designed model. The center is backbone area. Also called area 0. The petals are non-backbone area. Area 1, area 2, area 3. Okay. If you learn MPLS VPN later, you will learn the OSPF have 3-layer model. But now we teach everyone is 2-type design model. Okay. Why link state protocol need hierarchical? Why? In the CCNP book and the TCP/IP routing volume 1, you will see following answers. Because the performance of our network device is different. Some devices have lower CPUs and can't calculate too many routes, right? Some devices have a relatively small memory and can't store too many routes. Some devices have small bandwidth, so layered or hierarchical is needed because has the following benefits. Decrease the size routing table. How to decrease the size routing table? Summary, right? Summary can decrease the routing table, right? When the network topology changes, it does not affect other areas. No, this is filter or summary. Summary or filter can do this. Detailed LSA flooding will terminate at the ABR. This all benefits in our CCNP book or TCP/IP routing volume 1. You can see it. But one of my students went out for interview. The interviewer asked this question. My students studied very well and answered like the book said. But the interviewer interrupted him and said, "Now, our routers and switches are very powerful. We can easily store more than 10,000 routes. So why do we need the layered now?" Oh, this is good question. Why? Actually, easy control. Today, why we need a hierarchical in link state protocol actually is easy control. In later courses, we can learn OSPF can't perform summary and filtering in a single area. It can't perform a special operation on a single route in one area. Therefore, before control, the routes must be layered on ABR or ASBR. This will be described in detail later in course. Okay. Too fast. Discretion the size. Yes, actually, it's filter and summary. In ABR will be do this. Okay. Go on. This slide said the role of the router. Actually, this is backbone router. This is ABR. This is internal router. Backbone router in area 0. ABR connect multiple areas. One is area 0 called ABR. In the courses later, we'll discuss this detail. This is OSPF basic features. OSPF belong to IGP. Is link state protocol. IP protocol field is 89. If we know this value, so we can use this filtering OSPF package, right? How to filtering OSPF package? Sorry, I will start the router. Go on. Run SPF algorithm. Later, we will discuss SPF how to work. SPF calculate shortest path tree. Quickly responds the network changes. This is the OSPF function. In CCNP PPT, you will see EIGRP very fast. OSPF and ISS fast. RIP and BGP is slow. This is OSPF response network change very fast. Yeah. Sending periodic updates at a lower frequency every 30 minutes. This is called a link state refresh. Later we will discuss. When the network changes, it triggered the update. This means the update have three methods. One is a periodic update. Two is 增量更新。增量更新是怎么说来着？ The third is a triggered update. Support equal load balance. This is also called ECMP. But in service provider, the XR device support weight-based unequal load balance. If you study the CCNP, you will know EIGRP support unequal load balance. But in service provider, in XR device, actually the OSPF ISIs can support unequal load balance, but in this course, OSPF basic courses not have it because we focus on iOS, not XR, not XR. Okay, this is OSPF basic features. Let me start some router. CCNP router start. This is iLab CCNP lab menu. You will see switch basic topology, switch MSTP topology, router basic topology. Now we use option 5. Launch the router basic topology. Okay.
Thank you for watching. Visit our website below.
Present OSPF Basic Course, Part 2 by James.
Section 2 is important. Is 3 tables and the basic framework of OSPF. This part, the following courses are based on framework, so please memory it. It will be help you understand the OSPF. Okay. OSPF 3 tables. The first one is neighbor tables. Save all the neighbors information. We can use show IP OSPF neighbor to display the neighbor information. Okay. The second table is topology table, also called database or LSDB, link state database, used for save all the LSA. Here very, very important knowledge. This one. Everyone must be write down it. This is very, very important. Okay. The database of all routers in the same area is the identical. Later, lots of questions in the study can use this explain and the understanding. It's very important. Later, we can use this to explain lots of questions. Okay. And you can show IP OSPF database to display the LSA. Later, will be show it. The third table is routing table. The calculated best routes will be put into the routing table. You can use show IP route OSPF to display the routes. Okay, the 3 tables, neighbor tables, database or LSDB. The third one is routing table, the basic table in OSPF. Basic table in OSPF. Okay. The basic framework. This is very important. The whole basic courses is based on this. So please write down it and memory it. Later we can use it understanding OSPF. Okay. Let's read it. First, OSPF send the hello packet to the OSPF enabled interface. Compare several fields in the hello packet. If match, we'll put the peer into the first table, neighbor table. Show IP OSPF neighbor, you will show it. Okay, so we study how to enable OSPF interface, how to send hello package, which fields we must be compare and match. Then the neighbor will be established, right? This is the first one. The second is send LSA owned by the router self-database to the neighbor, and the LSA received from each neighbor will be put into the second table database. We can show IP OSPF database to display this. On this part, we need to know how to send, how to receive, how to put into the database, which one is newer, which one is older, right? Okay. The last one is run SPF algorithm to calculate the shortest path tree. This tree have two characteristics. One is shortest, the other one is loop free. Finally, put the calculated best routes into the third table, routing table. In this part, we need to know SPF algorithm how to work. I will teach you SPF how to work step by step. Okay. This is the basic framework, very important. Please write down and or snapshot. Later, we follow this framework to teaching. Okay. Okay. The second part, 3 table and OSPF basic framework is finished. You can see from section 4. We will be study.
Thank you for watching. Visit our website below.
Present OSPF Basic Course, Part 3 by James.
Okay, let's start the section 3. OSPF packets and the basic configuration. This is an example of OSPF packet. You can see that protocol number is 89 in IP packet in IP header. This can be seen in following labels. The 89. How to use this filter OSPF packets? We can use this access list. Access list 101 deny 89 any will be deny all OSPF packet. Access 101 permit IP any and apply under interface IP access group 101 in will be filtering all OSPF packets, right? Okay. Here is IP protocol number. Okay, go on. Next is OSPF basic header. This is OSPF basic header contain multiple fields. The version is version 2. OSPF have OSPF v2 and OSPF v3. v2 is support IPv4. v3 is support IPv6, right? Okay. Type indicate the type of various OSPF packets. Come here, you can see it. This picture in CCNP PPT, you will see the number and the OSPF packet. So type 1, if packet type 1 means hello. Hello, the function is establish and maintain neighbor relationship. Okay. This type 2 is database description. We can call it DBD. Some vendor also called DDP. DBD or DDP, which is DBD, database description. DDP, database description package. Some vendors called this. This is describe the summary information of LSAs in the LSDB. Okay. The type 3 is LSR. R means request. Which is used to request a specific LSA from the neighbor. Type 2, type 4. Type 4 is LSU. U means update. In LSU contains complete LSA information. LSA information. Type 5 is LSSEK. And is used to confirm receipt of LSU. If one router received LSU, will send back LSSEK. Okay. This is type. Next is packet length. Route ID. Route ID is very important. Area ID is very important. Both sides router must be in same area. Can be established neighbor. Later we will discuss. Okay. Checksum. Authentication type. Authentication password. Actually, not full password. And OSPF data part. We will learn one by one later. Okay. This is detail of OSPF basic header. No. Here. Here. One package. We how to see it. Basically, one line is 4 bytes. One line 4 bytes. If you want to know how many bytes of OSPF basic header, you just count how many line. 1, 2, 3, 4, 5, 6. So basic OSPF header is 6 line, 4 bytes. So the plus or 24 bytes of OSPF basic header. Okay. Route ID here. 4 bytes, area ID 4 bytes here. Okay. This is example. Okay, go on. Authentication and type and authentication the password. Later in authentication section we will discuss. Okay. Okay. This is OSPF basic configuration. It's a simple lab. Level 1. Level 1. We will start 2 routers. Use serial port connectables. S1/0. 1/0. Okay. Every route have a loopback 0. Loopback 0. R1 is 1.1.1.1/24. The R2 is 2.2/24. Okay. The link between them, the IP address is 10.1.xy.x/24. XY means router. X is smaller than Y. What it means? And R1 is R2, so here is 12, and R1 is 10.1.12.124, and here is 10.1.12 and .2/24. Okay. Later, if we have other router like R2 connect R3, so connect the link IP address is 10.1, 2 and 3, 23. Here is 2, here is 3/24. This is example. Later we use this. Okay. Now we just do the simple lab. Okay. R1 interface loopback 0 1.1. Okay. R2 interface loopback 0 2.2. Okay, /24. Okay. Ping test the direct connect. Ping 10.1 12.1. Okay. Ping worked. Okay. Now we configuration of the OSPF. OSPF have 2 methods. Configuration is 2 methods. One is this. One is this. R1 we use first method. Okay. The router OSPF 1 router ID 1.1.1 network 0 L1 network 10.1.12 okay. Okay, let's see it. The first line router OSPF 1 is enable OSPF the process ID is 1. Later we will discuss this. This is not important. Actually, one router can enable 30 OSPF process. This is maximum process. The second line is OSPF route ID. We manually assign OSPF route ID to the router. Okay. The next is network command. The first one is detail network. We can write the IP address, full IP address 1.1.1.1, and the wide mask is 0.0.0, and area 0 means this interface belong the which OSPF area. Now this interface belong the backbone area 0, right? The next is network is with mask network. Network 10.1.12.0. Actually, this interface in routing table you will see 10.1.12.0/1224. We use this, and the net mask is 255.0. This is net mask. One indicates the network bits. 0 means the host bits. This is net mask. White with mask is reversed. 0 means network bits. 1 means host bits. Host bits. 1 means host bits. So you need use with mask is 0.0.0.255. So this is a with mask network method. This is detail. Detail means use this and 0.0.0.0 for 0 and the network this part. Okay. But in actual work, some network is /28/29/14/15. You need to calculate with mask. Will be a little trouble on it. Actually, we can use network mask to enable OSPF like this. You can see it. If I have loopback 1, address is 11.11.11.1. If I will enable this interface to OSPF, route OSPF 1, we can network and copy address and IP address and network mask, copy paste area 0. Now you will see it will be will be change automatic to with mask, right? If in actual work you met not class A, B, C /8/16/24, you can use this way. We recommend this way to enable OSPF. Okay. Just copy and paste. If you have some interface, you can run section 255. Okay, you will see all this interface. Copy this, paste here, replace IP address, network, replace 0. No, 0, not good. And area 0, or you can just add a symbol. Area 0. Replace. Copy this and paste under OSPF. Right? Okay. And this will be enable interface. Enable OSPF interface. Okay. This is a tips. Okay. Go on. Area 0 here. We can use this way. OSPF network 1.1.1 area 0. No, this command, and type again. Area 0.0.0.0. Okay. Oh, now you can't see it. I can't see it. Some vendor, like Huawei or Juniper, use decimal format. You need to know how to translate. Area 0 and 0.0.0.0. This is number. This is dotted decimal. Why? We can see the slash before. Area ID actually 4 bytes, so we can use dotted decimal format. Decimal format. So we need to know how to translate. Example. If one site is area 513, if one area is 513, this is Cisco device. The other site is Juniper or Huawei. You need configure dotted decimal format. The value is, this is question. Yeah, this is question. All students, you can think and answer it. R1 is a Cisco device, 513 area. The R2 will be used dotted decimal format. Which value we should configure? type. I wait. I wait. Anyone can answer? Anyone can answer? From my understanding, you just Google it. There is one spare with 3. Yeah. Yes. This is this is OSPF with 3 new function. Actually, in iOS can do this, but XR don't. XR OSPF with 3 just support IPv6, not IPv4. Okay. No one answer. Actually, the value should be 0.0.2.1. This is means 513 area. How to do? How to calculate? How to translate? Actually, this is 32 bits. Sorry. CCNP. CCNP. 32 bits. That. Okay. And the last one is 220吧？这该怎么说？来看想一下啊。Sorry。0吧。20 power。2吧。Here is 2 to the power of 1. This one is 2 to the power of 7. Here is 2, 8 to 9. 2 to the power of 9 is 512. 512. So 513 means 512 plus 1. So you just write 0.0. Here is 1. Here is 0. Means 2, right? Means 2. 2.1 means 513. Means 513. Yeah. You must to know. You must to know how to translate the number and the dot decimal. Okay. The last one is network 0.0. 0.0 area 1. Area 0. Okay. This is enable all interface of this router. Here we can show IP interface brief. We can show how many interface we have and assign IP address 3. Or show IP interface brief include up. You will see it, and we add 2 interface. Look back 2 IP address 12.1.1. Okay, interface 3 IP address 13. Okay. Now we want to know which interface enabled OSPF. So IP OSPF interface brief, we can show how many interface enabled OSPF. Loopback 0, loopback 1, serial 1/0, 3 interface, right? If you do this command, network 0.0, 0.0, area 0, now you see, check again, OSPF interface brief, you will see all interface under enabled OSPF. So this command will be enable all interface of the router, enable OSPF, right? Okay. This is three command. This is detail network, with mask network, and enable all interface. Okay, these 3. R1 we config finish. Let's configure R2. Configure R2. Okay. R2 use the second method to enable OSPF. The decimal address 513 translate to yes. Okay. Okay. The R2 we use the second method config route OSPF 1 route ID 2.2. Okay. This is OSPF process. Now under interface we need track interface brief in up. Okay. Under interface we use this command IP OSPF 1 area 0. IP OSPF 1 area 0. Okay. Configure complete. You can see the second method is enable OSPF under interface, right? Under interface. This is new way for enable OSPF. The thing about it, compared with the first method, network under the OSPF process, what are its advantage? What is this method advantage? Actually, the advantage. Sorry. When the IP address of interface changed, like interface serial 1/0, you will be changed to 11.1.12.1. You will be network under OSPF process again, right? If you use a second method, you do not need to modify the OSPF configuration. Just modify the IP address is okay. So this is recommend method to configure OSPF. Okay. Okay. Now we can use some configuration, some command to show IP OSPF neighbor show IP OSPF database and show IP root OSPF. You can see OSPF routers, roots. Okay. Now this is OSPF basic configuration is finished. Is okay now? Have question? If not, we rest 10 minutes and later we'll go on.
Thank you for watching. Visit our website below.
Present OSPF Basic Course, Part 4 by James.
Okay. The start section 4 will be start basic framework. Now memory the framework. The first line. First, send the hello package to the OSPF enabled interface. Compare several fields into the hello packet. If match, we'll put the peer into its first table. In last section, we know how to enable OSPF on an interface. So next, we need to learn how to establish OSPF neighbor and agency. Section 4 include 3 subtopics. 4.1 the status of the neighbor and agency status. 4.2 the pyramids of neighbor and agency. The pyramids. Parameters. 4.3 is OSPF interface network type. Let's start 4.1. 4.1. The status of neighbor and agency. OSPF have basic 7 states of agency. Down, initial, two-way, X* exchange, loading full. Okay. Which is done? This means interface enable OSPF. Means on the interface we enable the OSPF command, or on the OSPF process we network this interface. But interface is done, like the administrative done. Okay, you will see this. Show IP OSPF interface brief. You will see the state, right? Okay. If we enable this interface under OSPF and this interface shut down, the administrative down, show IP OSPF interface brief. You will see this interface state is done. If you not enable this interface, show run section. I'll delete this command. Show IP OSPF interface brief. You will not able to show this command, this interface, because this interface not enable OSPF. So downstate means interface enable OSPF, but the interface is done. This is done state means. Okay. Next state is initial. What is initial? One router receive hello packet like R1, R2, R1 receive R2 hello packet, and match all parameters of hello. But neighbor list, what is neighbor list? You will see the hello packet. Hello packet like this. The upper 24 bytes is OSPF basic header. The type equal 1 means hello. Type 2 means DBD. Type 3 means LSR. 4 LCU5 LCSEK. So hello used for establish and maintain neighbor, OSPF neighbor and agency. So type 1 is hello. The following field is hello data. Here is a neighbor list field. The initial state means one router received the other side hello and match all parameters of hello, but neighbor list field is none. The first hello neighbor list absolutely is none, because he not establish neighbor and agency to anyone. So the neighbor list here is none. Means other side did not treat me as a neighbor. So the state will be initial. The state will be initial, right? Okay. Means I receive, but neighbor list is none. So I will be treated. R2 is initial. In lab, we not never means very less chance to see this state. Very less chance. Okay, we can try do this. R1 and R2 shutdown interface. So S1/0 short interface brief. Serial 1/0 means done, right? Okay. Now we use access list on R2. Here we apply access list. Access list 1.101. Deny OSPF any. Access list 101. Permit any. Interface S1/0. IP access group 101 in. That means deny all OSPF packets. So R1 sent to R2 hello will be denied. So R2 never treat R1 as a neighbor. So neighbor list is 0, is none, right? Okay, check it. No shutdown. Yes, no shutdown. Show IP OSPF interface brief. Okay, see it. Never see it. Show IP OSPF neighbor. You can see initial stage. right? Initial. Initial means you receive the other side packet, hello packet, and match all parameters, but neighbor list not include mine, include me, not include me. So we R1 treat R2 is initial state. Okay. Okay. The third state is two-way. Two-way means receive other side hello and match all parameters. The neighbor list field have information of me, of mine. Okay, means other side treat me as a neighbor. Okay. First package R2 send to R1. A neighbor list is none. R1 treat R2 is initial and send hello to R2. The neighbor list include R2. Include R2. Send to R2. So R2 receive hello packet. And match all parameters. The neighbor list field have information of mine. Means outside treat me as a neighbor. So state will be two-way. R2 treat R1 is two-way. It's two-way. If this port is multi-access network type, here will be choose DR and BDR. Later we will be discuss this. Now do not need. Okay. This is two-way. Two-way and initial. The difference is hello neighbor list is none or have information of mine. Okay. Then the third package R2 send hello to R1 neighbor list have R1 information. So R1 will be treat R2 is two-way. Is two-way. So both sides treat other side is two-way state. The neighbor established. So this process we called three-way handshake. 三次握手 three handshake to establish OSPF neighbor. So both sides treat other side as a neighbor. The state will be two-way. Because now this example is serial interface. So two-way is very shortly state. If this interface is Ethernet, the state will be longer, or will be long. Now is shorter. If you want to see it, you can see. IP access group 101 in no. Treated. No. Show IP OSPF neighbor. No. Neighbor. Oh, sorry. Neighbor. Check it. Oh, you not see two-way, right? You not see two-way. Actually have two-way state, but very quickly. You see exchange full. You can't see loading. You can see Xstart, you can see two-way. Actually have this state. Later we will be debug. We will be see this state. Okay. If we use Ethernet 10.1, 100, 1, IPOS 1, error 0, 10.1, 100, IPOS 1, error 0. Okay. Now you will be say, okay. So like also neighbor will be see the two-way state. Yeah, two-way state. Because the multi-access network type will be choose DR and BDR, right? Later we discuss this. You see, this state is okay. This is third stage. The fourth stage is Xstar. Xstar. This is first agency stage. This is neighbor state. This is agency state. In OSPF we have neighbor. What is neighbor? Two-way means neighbor established. What is agency? Established. Full means agency established. Xstar means agency start. Agency start. Okay. And the Xstar stage use the first DBD package. Use first DBD package. Send DBD. First DBD. First DBD. First DBD. The first one. First. First DBD not including LSA information. Not including LSA header. The first DBD, the function is choose master and slave relationship. Must slave relationship of routers and negotiate both side MTU and negotiate MTU. Later we will be see it how to choose master and slave, how to negotiate MTU. Okay. The first DBD means Xstar. Later will be send DBD. This is not first DBD, not first DBD. Okay. DBD is a package. Is used for description the LSA information of myself of the router. Database have the LSA information to other one. Description LSA summary information to of its database. Loading is this process. Send LSR to request specific LSA. Send LSU to for your request, and send LSACK to confirm receive LSU. This is loading processing. This is exchange. This is Xstar. Xstar. If all LSA received, a database synchro synchronized, both sides will be full. the state will be changed to full. Changing will be to full. We can use a lab to prove it. Okay, you can see the picture. The start interface enable OSPF but shut down. So interface state is down state. Receive packet, receive hello, but neighbor list not have me, have my information. So will be initial state. And receive hello, other side hello. Neighbor list have information of mine. Then I will treat other side will be two-way state. Okay. X star send the first DBD. First DBD used for choose master and slave state role. The role of master and slave. And negotiate MTU. Exchange. Send DBD to other side. Description. We have which I will say. Okay. The loading for loading else R, else U, else ACK. This is loading state. The full state means all LSA I received. This is the seventh state of OSPF. Establish neighbor and agency. Okay. This is seventh stage. Okay. Now we use a lab. We create a lab to prove it. Okay. Same topology R1 and R2. Same topology. R1 and R2. Serial 1/0. Loopback 0 and enable OSPF. Okay. R1 shut down. R2 shut down. Shut down. Is net 0 shut down. Okay. We need to see the OSPF establish neighbor and agency process. How to say debug IP OSPF package. Debug IP OSPF agency. Debug IP OSPF event. The three debug. Debug IP OSPF package, event, and agency. Okay. No shutdown. Serial interface. No shutdown. No shutdown. Okay. No shutdown. You will see the debug information. Oh, lots of information. Don't be afraid. It's easy to read. Okay. Undebug all. Undebug all. Show IP OSPF neighbor 4. Okay. Cool. Now we will read this information. Sorry. Okay. Now we will be see this package out The source address is interface of IP address. The destination IP address is the multicast address 224.0.0.5. OSPF have two multicast address 224.0.0.5 and 6, right? Almost is 5. Version 2. Here is the OSPF basic header. The version 2 type 1. Type 1 means hello, right? Type 1 means hello. So we send hello outgoing to serial interface. Okay. Receive the package is type 1 means receive the hello package, right? Okay. Out hello packets. Okay. Now this is established neighbor. So we'll be see the initial state and the two-way state. Initial state, not both sides will be seen. Not both sides. Because one side send R2 send to R1, R1 neighborlist none. So R1 treat R2 is initial. If R1 first send to R2, a neighborlist is none, so R2 treat R1 is initiate, right? The second hello will be R1 treat as R2 is two-way, so not both sides see initial state, not both sides, just one side treat other side is initiate, just one. Okay, so R1 not see initial state, just see two-way state. Just see two-way state. After two-way will be send DBD, first DBD. This is DBD. Type 2. Type 2 means DBD, right? Okay. I said first DBD not including LSA information. First DBD, the function is choose the role of master and slave and negotiate MTU. So you will be see this. You will be see this. Send the DBD to R2. Have some information of DBD packets. Sequence 296. Okay. DBD. I send sequence 296. Option ignore it, later we discuss. Flag 7. Flag 7. The packet length is 32. Packet length is 32. This is first DBD. 32 length. Okay. This is R1 sent to R2, right? R1 send to R2. This is receive the R2, the DBD packet, first packet. So you will see sequence is 1 hexadecimal. No, not hexadecimal. Hex 1969, 68, 1968. 1968 flag is 0 hex 7, length is 32. Where is it? Here. Flag length 32 MTU. This field used for choose role and role of master and slave. This field is negotiate MTU of both sides, right? Okay. Now sequence is a random number of both sides. Flag have a special means. What is means? Okay, we will be see the package. DBD. DBD. Oh, sorry, I found it. DBD. 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 Where's SAK? Where's DBD? Here is DBD. Okay. Here is DBD. Upper 24 bytes is basic hello basic OSPF header. Type 2 means DBD. DBD have MTU options and flag and a sequence and LC header. The first DBD package not include the LC header, just include this. You can see the flag have 3 bits. I means initial. I means initial. If this package, this DBD packet is first DBD, this bit will indicate 1. First package will be assigned 1. The M means more. Means next I have another DBD. Next I have another DBD. If not have DBD description LSA, this bit will be assigned 0. 0 means last DBD. 0 means last DBD. 1 means I have another DBD. I have another DBD. Okay. MS master and slave. From the start, everyone treat myself as master. No one treated as slave, right? So the first DBD is initial the first package. Next have another package. One master and slave. Master is 1, slave is 0. So 111 means 7. Right? 111 means 7. So here Okay. Okay. Here, why the first packet flag, first DPD, the flag is hex 7. Why? This is initial 1, more 1, and MS 1, right? Okay. The both side will be choose the master and the slave. How to choose? Use route ID. Route ID large. Route ID large will be choose a master. Large will be choose the master. Or route ID higher. Higher is okay, is good. Higher. Route ID higher means must. Means must. So R1 is 1.1 is route ID, R2 is 2.2. So R2 will be must, right? You can see it. Receive state is X star. The first DPD is X star. Neighbor negotiate down. We are slave. The R2 we are master because R2's route ID is higher. It's higher. Okay. Now. The third DPD, R1 will be sent and R2 will be sent. R1 will be sent and R2 will be sent. Is slave will be sent. Slave will be sent. Just like wasting. The slave will be sent the third DPD. The third DPD. The third DPD. Because R1 is slave, so it will be sent the third DPD. Okay. The sequence use master sequence. Use master sequence. Sequence 1968. Flag. This is first package DPD. No, 0. The net have another DPD. Yes. You are slave or master. We're slave, so 0. 0, 1, 0 means 2, right? So flag will be 2, hex 2. Length will be larger, will be higher, not 32. Because the first package, first DPD, not including LC information, so small. The next DPD will be bigger, because including LC header. Let's see it. Oh, let's see it. R1. So send the second DPD. DPD to R2 sequence use master sequence. Option flag. Sorry. Here. Flag is hex 2. Why hex 2? I said this is first no 0. This is last no 1. Slave or must. Slave means 0. So flag will be hex 2. Length you will be see the bigger, right? Bigger than the first. The first is 22. Here higher, bigger, bigger. Okay. Why use sequence of master? Why use this? Why use this? This is used for confirm. I confirm received your other side DVD. You will be see what's your package. Hello. Not confirm. Not need confirm. Not confirm. DVD. else R, else U, else ACK. This package you have explicit confirm a method. If I send LSR, you must send LSU. I must send LSACK to confirm receive LSU. This is explicit confirm method. The DBD not have this confirm method. How to check we received? How to confirm I received other side DBD? How to confirm? Use sequence. Use must send 1968 to slave. Slave send 1968 confirm receive must DBD. Must received 1968 will be sent 1969 and the slave response reply 1969. 1970. Use sequence to for confirm receive other side. So must be choose the role of master and slave, then use must sequence. We can confirm receive the other side DBD package. So you will be see the process. Receive DBD 1969. Out send a DBD 1969, right? If this is a last DBD, the flag will be sent assigned to hex 0. The slave will be hex 0. The master will be assigned configured to hex 1. 1 means master, 0 means slave. The initial, not first package 0. The last package 0. Must 1. Hex 1. Hex 0. The slave must. This is this is the last DBD. Okay, this is exchange state. The following is loading and fall. Okay, you will be say loading and fall. is type 3, type 4, and type 5. Type 3 means LSR, type 4 means LSU, type 5 means LSACK. So the OSPF establish neighbor and agency process done. Done. So we receive all information of other side and calculate the OSPF routes put into the routing table. Okay, this is the process of OSPF establish neighbor and agency process. Everyone know it, understand it, or not? Have any question? Have any question? Any questions? No? Okay.
Thank you for watching. Visit our website below.
Good morning, everyone. Today we continue the OSPF course, the day 2. First, let's review the OSPF framework yesterday. We will continue to talk about it. First, now we review the framework. The first, send the hello packet to the OSPF enabled interface. Compare several fields in the hello packet. If match, we'll put the peer into its first table, neighbor table. You can use show IP OSPF neighbor to display all neighbors information. This is the first step of the framework. Yesterday we know how to enable OSPF on the interface, and we know OSPF establish neighbor and agency use or 经历怎么说？several state down initial two-way start exchange and loading full. Today we should learn which parameters must be matched when establish the neighbor. Okay, so the 4.2 section is learn parameters of establish a neighbor. Okay. Here is a picture of hello packet. The above 6 lines are basic headers. Above 6 line. Here is OSPF basic headers. Starting with the network mask. This is the data part of the OSPF hello packet. We can see there are several parameters. Network mask, hello interval, option, router privacy, data interval, design the router, designated router, 然后 backup designated router, DR, this is BDR, right? And this is BDR, and neighbor list, we use hello package to establish the neighbor. Use DBD, LSR, LCU, LSACK to establish agency. So maybe MTU or other parameters will be affect the agency. Later we discuss. Now that we have collected some parameters that may affect the established neighbor or agency, let's test one by one. Okay. The first, okay, here we collect the 12 parameters. The first is interface network type. This will be discussed in 4.3 seconds. So we start here. From hello interval and to authentication password. These parameters are necessary for establish a neighbor and must be matched at both sides. Let's test hello interval, dead interval first. Okay. We use topology. Use this. I write down on the notepad. R1, R2, same as yesterday. Loopback 0, 1.1, loopback 0, 2.2. The link between the 10.1.12/24.1.2. This is the basic IP address of the routers. Okay, now we configure it. Interface loopback 0. 10.12. Okay. R2 2.2. Loopback 0. Okay. Now loopback 0. The interface IP address configure complete. Ping 10.1.12.2. Okay, the ping worked. Now we configure OSPF by basic configuration. Route OSPF 1, route ID 1.1, network 1.1, 0.0, area 0, network 10.1.12.0 255. Okay, R1 complete. R2 route OSPF 1, route ID 2.2, interface loopback 0, IP OSPF 1, error 0, S1/0, IP OSPF 1, error 0. Okay. Now OSPF neighbor is established. Show IP OSPF neighbor. You can see the other side, and the state is full. State is full. The DRBDR role is none. Okay. We test the first parameters. Hello interval and dead interval. In hello package. Here is hello interval. Here is dead interval, right? Okay. Hello interval means how long time send a hello package out of the interface. Dead interval means how long time I did not receive the hello from the neighbor. I think the neighbor is invalid. The default dead interval is 4 times the hello interval. Now we show OSPF hello interval and dead interval. Show IP OSPF interface S1/0 interface. Okay, now you can see lots of words. The first line is serial 1/0 interface is up, line protocol up. It's simple. The second line interface address, IP address, and belong to which area 0. Belong to which OSPF process 1. Route ID 1.1, network type point to point. This will be discussed in 4.3 section. Cost, topology, cost, transmit delay in LSA synchronization part. We discussed this. Time, hello time 10, dead time 40, wait time 40. You can see the hello and dead 10 and 40. You can see dead interval default is 4 times of a hello interval. Okay. If two routers want to establish OSPF neighbor, the hello and dead interval on both sides must be same. How to change hello and dead interval? Let me try. R2 is same. Show IP OSPF interface S1/0. Can see hello and dead interval 10, 40. How to change it? Okay. IP OSPF hello interval 20. Okay. Let me show again. Show IP OSPF interface S1/0. You can see the time changed. Hello 20, dead 80. If the hello time is modified, the dead time will be changed. Same time, right? Dead time change to. Okay. Now you can see the OSPF neighbor down, broken, right? Show IP OSPF neighbor. You can't see neighbor because R1 we don't modify the hello and dead interval. So hello dead is 10 and 40. R2 we change hello 20. The dead change to 80, right? Automatic change. So two routers want to establish OSPF neighbor. The hello and dead interval must be matched. Okay, and now we change dead interval. Try interface S/1/0. Okay, IP OSPF dead interval. Dead interval 40. 40. Okay, show IP OSPF interface S1/0. You can see the hello dead 20, 40. If you change dead interval, the hello time hello interval will not change automatic. Okay, so hello change, that change or that time will change automatic. If you modify that interval, hello interval not change automatic. Okay, this is the result. Now we know if two routers want to establish neighbor and agency, hello and data interval must be matched. The hello and data interval function they used to determine when the neighbor is invalid. If in actual work, if the two devices are directly connected, like this topology, R1 and R2 use link connect, direct connect. We don't use this parameter because optical signal and electrical signal of the physical interface. If one interface shut down or the link broken, the other side will be very quickly down because the optical signal or electrical signal. So OSPF can quickly know that the neighbor is invalid and switch to another path. When we use this parameter, hello and data interval, if two routers are connected through a switch or a transmission device like MSTP, this topology, if one side failed, the other side can't perceived. This parameter will be needed to determine whether the neighbor is invalid. Right? This parameters smaller is better. Why? Because we can sooner precede neighbor invalid, and sooner we can switch to another path, and sooner the network can converge. So what is the minimal hello and data interval? What is the minimal? Let me see. Okay. Interface S/0 IP OSPF hello interval. You can see hello interval, the minimal is 1. The data interval, OSPF data interval, the minimal is 1. But here another option, minimal. Minimal hello multiplier is like 3 to 20 you can set. Hello multiple, this command, the means is we set the data interval is 1 second. We set the data interval is 1 second. The hello multiplier means how many hello packets send in 1 second. Number of hello sent within 1 second. Okay. So R1 this device hello data interval is 1 second. Hello interval is 333 milliseconds. We show it. So IP OSPF interface S1/0. You can see hello interval is 333 millisecond, and data interval is 1 second. Another R2, another side R2, we change IP OSPF data interval minimal and hello multiplier 4. So you can see the parameters. Hello interval 250 millisecond, data interval 1. Now data interval same, but hello interval not same, different, right? OSPF neighbor can establish a neighbor or not. So IP OSPF neighbor, you can see the OSPF neighbor established. Why? Now mismatch hello interval. Why can establish the neighbor? Because the one hello interval below 1 second will treat as 1 second, so can be established OSPF neighbor. Everyone must be know it. Okay. If hello interval below 1 second, treat as 1 second. Okay. So you can see the hello interval and data interval affect the OSPF neighbor. In actual work, if you in actual work, if you want to determine time less than 1 second, like in 50 milliseconds or 200 milliseconds, you can use another technology, BFD. Where is my pen? BFD. BFD means bi-directional. Forwarding detect. Detection. BFD means bi-directional forwarding detect. This is in actual work. Many time used. Very useful. This is not our class topic. If you want to discuss, you can email me or add me Skype. Discuss this. Okay. Skype, ACHING 777. Skype. The email ACHING 0116 at gmail.com. Okay. Now I just provided the command of BFD. If you have interest in later, you can find some documents to understand it. Okay. The BFD configuration. R1 interface S1/0. BFD interval 50 millisecond. 50 minimal receive 50 and multiplier 3. Okay. IP OSPF BFD. Show run interface S1/0. You can see the two to command. R2 interface 1/0 IP BFD interval minimal receive, and multiplayer 3 router OSPF 1 BFD all interface. You can configure BFD under interface or under OSPF process. The same result. Okay, now show BFD neighbor. You can see through the BFD technology, we can perceive another site, right? So BFD neighbor detail, you can see the parameters. But this technology not in this topic. If you want to discuss, mail me. Okay. Okay, this is the first two parameters. We see if you want to establish OSPF neighbor, these two parameters must be matched, right? Okay. Next, area flag, actually option field. These parameters will be discussed in OSPF special area part. Now we don't discuss this. In advanced course, special area part, we discuss this. Area ID. Area ID, we see it before. Must be matched. If not matched, can't establish neighbor. If mismatch, we will got a log information. You can see it. Interface is net 0/0. IP address no shutdown. IP address 10.1.100.1. IP OSPF 1 error 0. R2 interface is net 0 no shutdown. IP address 10.1.100.2. IP OSPF 1 area 1. Now R1 is net belonged to area 0. R2 is net belong to area 1. Okay, you can see we will got the log message. Received invalid packet, mismatch area ID, right? This means if area ID mismatch, we can't establish OSPF neighbor. Show IP OSPF neighbor, you just see we through the serial interface establish neighbor, but not through the Ethernet interface, right? Okay. So shut down this interface. Shut down. Oh, sorry. Ethernet interface. Shut down. Ethernet interface. Shut down. Okay. Area ID. Other two parameters. Authentication type. Authentication password. Will be discussed in advanced courses. Not here. So the first 6 parameters are necessary match in establish OSPF neighbors. Okay. Now we discuss the other parameters. Okay.
Thank you for watching. visit our website below.
Okay, the next one is network mask. Okay, we modify network mask on R1. Modify network mask R1. R1 modify to /25. R2 not change /24. Okay. Let me check OSPF neighbor is established or not. First, we shut down R1 or R2. Shut down. Shut down. Shut down. IP address 10.1.12.1 255.255.255.129. Okay. Now no shutdown interface. We will see OSPF neighbor can establish or not. Okay, show IP of the neighbor. You can see through serial interface we establish OSPF neighbor. So modify network mask on serial interface not affect OSPF neighbor, right? Okay. In PPT we can see explain. One network mask will be affect the OSPF neighbor in multi-access link environment. Let me check Ethernet interface again. Okay. Interface Ethernet IP address 10.1.100.1 IP OSPF 1 error 0. Okay, no shutdown. No shutdown. R2 10.1.100.2 IP OSPF 1 error 0. No shutdown. We should be C. We should see the first one. From the start, we can establish on Ethernet or not. Now the net mask is same. So run interface Ethernet the same, and both sides belong one area, same area, error 0. Error 0. Right? Show IP OSPF neighbor. You can see through the Ethernet interface, you can establish the OSPF neighbor. Not yet change or IP address and network mask. Not yet. Now we change the mask. Let me see. Okay, R1 IP address 10.1.100.1 255.255.128. Okay. Now you can see OSPF neighbor is down. So IP OSPF neighbor. So IP OSPF neighbor. Oh, here neighbor. You can see the time 40 now 15 now 15 and change every time. Now OSPF neighbor broken, right? Show IP OSPF neighbor. We can see if a network mask different on both sides, the OSPF neighbor if use serial interface, we can establish OSPF neighbor. but in Ethernet interface can't establish OSPF neighbor. Why? In LSA type part, we can understand it. Now you just need memory. A multi-access topology need match network mask. You just memory. In LSA part, we will understand it. Okay. Next, route ID. Route ID can affect the OSPF neighbor or not. Let me see route ID where we discuss some parameter. Area ID here. No, we discuss route ID here. Actually, the route ID is used to identify a device, and it recommend to be unique. Recommend to be unique within the entire OSPF domain. Recommend every route different route ID. Now I just ask a question as a mission, as a homework. Please don't say it to me. Mission impossible, okay? Okay. Now we got 3 example. The example 1, 2 router direct connect. My pen. Where is my pen? Okay, here. R1, R2 direct connect, and R1 and R2 use same route ID. The question is can be established neighbor or not? Neighbor can be established or not? Routes have problem or not? You can receive the other side routes or not? Routes. Okay, this is example 1. Example 2, R1, R2, R3. R1, R2, R3 in same area, belong to same area 0. Okay, R1 and R3. R1 and R3 have same route ID. The question is, can be established neighbor or not? With R2, the neighbor will be established or not? The routes have problem or not? Routes have problem or not? This is question 2. The question 3, R1, R2, R3. R1 and R2 belong to area 0. R2 and R3 belong to area 1. Then R1 route ID is 1.1, R3 route ID 1.1. Use same route ID. This environment can be established neighbor or not, and the routes can learn or not, have problem or not neighbor. Have problem or not, routes have problem or not. These are 3 questions as the homework. You can do it by yourself. If you got answer, you can message me or use Skype or email me. Later in LSA part, we'll discuss this. Actually, the result very interesting. Very interesting. Okay. If you do this levels, so you will know why OSPF recommend route ID must be unique within entire OSPF domain. Okay, this is very interesting levels. If you have result, tell me, message me. Okay, this is result route ID. The next one is process ID. Process ID. The process ID same or not affect OSPF neighbor. Affect? Not? Let me try. Okay. My pen, where's my pen? Okay, here. R1 and R2. R1 is OSPF 1, R2 is OSPF 2. Now, OSPF neighbor can establish or not. We test it. Okay. In level, you can use this command, no IP routing and IP routing. This command will be delete all protocol on this device. In actual work, please don't use this command, because this will be delete all protocol in your device. Now your network will be broken, will be done, right? In lab you can use it. Okay, route OSPF 1, route ID, no, route OSPF 1, no IP routing, okay. Network 1.1, 0.0 error 0, network. Okay. This is R1, R2, route OSPF 1, no. R2 is route OSPF process 2, route ID 12, interface loopback 0, IP OSPF 2, error 0, S1/0, same command. You can see the OSPF neighbor established. So IP OSPF neighbor, you can see the both sides both sides use different OSPF process ID. We can establish OSPF neighbor. Why? Why? Actually, this is simple questions. Because the hello package don't have process ID parameters, right? You can see all the parameters not have process ID. So these parameters can't carry on in hello, so not affect OSPF neighbor. Okay, now I ask another a question. If two OSPF process network same link, two OSPF process, R1 run two OSPF process, OSPF 1 and OSPF 2, and all network this link. All network this link. Now, which process will establish neighbor with other side? With R2. Right? Now we test it. Router OSPF 2, router ID 1.1.1.2, network 10.1.12.0, 255.0.0. Show run section RO. You can see router OSPF 1 network this link, router OSPF 2 network this link too, right? Now we will see which OSPF process will establish neighbor with R2. How to do? Clear IP OSPF process. And yes, the OSPF will re-establish neighbor. You can see which OSPF process 1. Why process 1? Why not process 2? Because we have a conclusion. One link just belongs to one OSPF process. One link just belongs to one OSPF process. You can use this command, show IP OSPF interface brief. You will see serial interface belong to OSPF process ID 1, process 1. This is interesting things. That's why in exam or lab, I can add a trouble to you. You will feel the configuration all correct, but can't establish OSPF neighbor. Let me try again, okay? Let me try to add trouble to you. No route OSPF 2. Okay. In exam, you asked to configure OSPF R1, you configure like this. Router OSPF 1, router ID. After you configure, you can establish OSPF neighbor with R2. Show IP OSPF neighbor, right? Now I am a protocol. I add trouble to you. You can't see it. Now I add a trouble. The first one, the first step, delete OSPF 1, process 1. Open Notepad. Copy your configuration here. And delete your configuration. The second step, add OSPF 2 network this link. Route OSPF 2 network 10.1.12.0 255.0. Now this link belongs to OSPF process 2. Show IP OSPF interface brief. This link belongs to OSPF process 2. Now, the third step, add OSPF process 1, add your configuration back to router. Okay. Oh, router OSPF 2, network 1.1.1.2. Sorry, 1.1.1.2. Clear IP OSPF process. Router OSPF 1, router ID 1.1.1. The third step, add your configuration back. But this link belongs to OSPF process 2. Show IP OSPF process neighbor interface brief. This link belongs to OSPF process 2, right? The fourth step, delete OSPF process 2. Now you can see your configuration not change, same as your configuration before, but the OSPF neighbor can't establish. In exam, if I add this trouble to you, you will see OSPF neighbor can't establish. And surrounding configuration or configuration, you will see all configuration same as before, but OSPF neighbor broken. Can't establish. How to solve it? How to fix this problem? Okay. Actually, save configuration and reload. This is magic method. Some issues will be solved after reload. In exam, same configuration and reload is magic. Must be you need to use this method. Any other method can fix this configuration, this problem. Actually, you need to know why. Why have this problem? Because the one interface belongs to one OSPF process. If show IP OSPF neighbor can't see another side, the first one you need to show IP OSPF interface brief. You can see the serial interface not here. Not here means not enable OSPF. How to fix it? You can use two methods: shutdown and no shutdown this interface, or delete network command and retype it. You will be fix this issues. You can see your OSPF command. Actually, your command is right. It's correct, right? You can shut down and no shutdown. The OSPF will be re-enabled on this interface. Or you delete this command and retype it, will be fixed these issues. This is the little trouble. Interesting. Okay. Another question: if two process network same link, now you know. If I type router OSPF 1 network 10.1.12 L0, router OSPF 2 network 10.1.12, which OSPF process enable this link? Show IP OSPF interface brief. You can see actually OSPF process 1. This is early configure OSPF process will be enabled this interface, and this interface belong early OSPF process. But if this router reload After booting, which OSPF process will be enabled this interface? Or after booting, this interface will belong to which OSPF process? This, in actual work, this is a bug. If device not same, OS not same, result may be not same. So if you met these issues, causes attack. This is actual issues in our work. But best practice: don't network same link in different OSPF process in a router. Okay. Okay. This is the process ID. The next is interface MTU. In 4.1 section, we know first DBD will be negotiate the MTU. Oh, sorry. I'm sorry. The first DBD will be entering X star state. The first DBD will be negotiate MTU. This is IP MTU issues. Both sides must be matched. We can see if R1 and R2 are different, or MTU will be got issues. Okay, R1. The default MTU is 1500. R2 is 1500 too. Now we modify this to 1400. Okay. Actually, MTU have a layer 2 MTU and a layer 3 MTU. I'm not discuss this. Actually, now L3 MTU must be matched. IP MTU 1400. Okay, 1400. Now clear IP OSPF process. Why? Yes. Now you can see IP OSPF neighbor will be stuck in X-start or exchanging state. X-start. Some iOS, some device you will be X-start exchange. Why? Why stuck this? Why stuck this state? Because the MTU belong to DBD. We use DBD negotiate. First DBD will start start state, right? How to fix it? You can configure same IP MTU on both sides, or use another command. IP OSPF MTU ignore. IP OSPF MTU ignore. Use this command. Question is this command need to configure on small MTU side or bigger MTU side on both or both. Small MTU side. This command need to configure small side, bigger side, or both. Or both? This is a question. If you have answer, please type in chat. type in chat. Anybody have answers? Okay, actually, we need type this command on smaller side is okay. Not need configure on both. Let me try. IP OSPF M2 ignore. Show IP OSPF neighbor. You will be see OSPF neighbor established. Done. Oh. Why done? Because too many retransmission. Right, so OSPF state is changed to done. You can wait some time. He will restart the OSPF process or clear IP OSPF process. Ask OSPF reprocess. Show IP OSPF neighbor. Show IP OSPF neighbor. You can see OSPF neighbor established. I configure this command on R1. Okay. Why? Because if your M2 is small, send to R2, R2 can accept. But if you configure R2 here, R2 send 1500 package to R1. R1 can't accept, so you need to configure ignore here. Ignore it. Then will be accept the 1500 package, right? Okay. This is M2 issues. M2 issues. And the last one is network and passive interface. Network and passive interface. Passive interface here. Passive interface S/1, S1/0. Oh, if you passive interface, it will be enabled on process 2. Okay, no rather OSPF 2. Show IP OSPF neighbor. Show run section OW. If one interface passive, this interface can't send any package. In RIP, can't if you passive interface, this interface can't send routes, but can receive routes, right? OSPF, if passive interface can receive or not routes, can receive or not routes? Actually not. Why? Because if not send hello, so can't establish neighbor. If can't establish neighbor, so can't send and receive LSA, so can't calculate the routes, right? So in OSPF, if you passive interface, so this interface can't establish any neighbors. Okay, now all parameters we discuss. Some parameters we'll discuss in advanced course. Okay. Now we know which parameters will affect established neighbor. So 4.2 seconds are done. Rest 5 minutes. Okay.
Thank you for watching. Visit our website below.
Okay, go on. 4.3. OSPF interface network type. The link type have two concepts. One is concept of layer 2, and the other is concept of layer 3. First, let me talk concept of layer 2. Layer 2. Point-to-point interface. Point-to-point interface. Point-to-point link. Which is point-to-point link? The packet outside the interface only can reach one device. Only can reach one device, not two, not three, just one. That is point-to-point link. That is point-to-point link. Which link is point-to-point link in layer 2? If interface encapsulation, HDLC, PPP, or frame relay point-to-point sub-interface, this will be P2P link. P2P link. The second link type is a multi-access network. Multi-access network means if packet go out to interface will be or can be reach some device. Which can be reached this, can be reached this, can be reached this device. So this is multi-access network. This is layer 2 concept. Here is broadcast. Broadcast multi-access have Ethernet, talking ring, and FTDI. Ethernet is the many layer 2 technology. Another is non-broadcast multi-access. Frame relay in routing and switching CCNA exam is removed. So we not discuss this. Okay, this is layer 2 concept. Go on. Now we discuss layer 3 OSPF network type. This is layer 3 concept. Affect this OSPF network type will affect OSPF operation and calculation, regardless of the actual interface type, layer 2 link. Here, OSPF have this OSPF network type, point-to-point broadcast. NBMA point to multi-point non-broadcast, and loopback. We will discuss one by one. But NBMA this link actually he match the frame relay interface, but frame relay removed in routing and switching exam, so not discuss this type. Not okay. Here we have a table. Here we have a table to compare interface network type parameters. Okay, we discuss one by one. First is loopback. One loopback interface enable OSPF loopback interface. enable OSPF, which interface network type will be loopback? Let me see. Router OSPF 1, no passive, S1/0. We add new loopback 1 IP address 11.11.1 and /24. Route OSPF 1 network this interface. Error 0. Show IP OSPF interface brief. You can see loopback 1. One. Oh, clear. Shut down. Interface S. Shut down. Shut down. Same issues as before. Show IP OSPF interface brief. You can see loopback 1 below. Enable OSPF and type is loopback. We can show IP OSPF interface loopback 1. You can see the network type is loopback. So one loopback interface enable OSPF, which interface OSPF network type will be loopback, right? Can see you can see the hello and data interval. No, because loopback network type not send hello and will be treated as a host root. So hello data interval now will be choose DR and BDR? No. Will be generate 32 host roots? Yes. You can see here. In R1, this interface is 11.11.11/24. But in R2, show IP root, you will be see the roots of 11 is 32 network mask. So the loopback network type will be generate host roots, right? Host roots. Okay. This is loopback network type. Oh, second type, point-to-point. One interface encapsulation HDLC, PPP, frame relay, PPP, P2P subinterface. The default OSPF network type will be point-to-point. Huh? Now can't see a screen? Hello? Everyone? Can you see my screen or not? Can you see my screen or not? Hello? Oh, okay. Okay, go on. One interface encapsulation HDLC PPP, frame relay P2P subinterface. The default OSPF network type will be point-to-point. This network type, hello and data interval will be 1040. Okay, let me see. R1 use serial interface, show IP OSPF interface brief. You can see serial interface enable OSPF. This interface encapsulation, which protocol? show interface S1/0. You can see encapsulation HDLC. This is default Cisco operate, right? Other vendor maybe default encapsulation PPP. Okay. If interface encapsulation HDLC enable OSPF show IP OSPF interface brief, you can see this interface the network type is point-to-point. Show IP OSPF interface S1/0. You can see the network type is point-to-point, right? And hello data interval 1040. I modify it. Show run interface S1/0. I need to delete this command. And R2 same. Okay. I want to show IP OSPF interface S1/0. You can see the back to default value. Hello and data interval 1040. 1040. Okay. Go on. Need to choose DRBDR? No. Will be generate /32 host roots? No. We can test. We can test. In our router, loopback interface can be changed to network type. Network type can be changed to point-to-point. Before changing, in R2 show IP root, you can see 11. This root is 32 host roots, right? I want to change IP OSPF network point-to-point. We change loopback 1 OSPF network type to point-to-point. To point-to-point. Now you see again. Check again on R2. You can see 11. This route will be 24. 24 network mask. So the point-to-point network type will not generate host roots, right? So this is right. This is right. Okay. The point-to-point interface is okay. Next is broadcast. Broadcast. When Ethernet interface enable OSPF Ethernet FDDI. I not met. I just met Ethernet. When Ethernet interface enable OSPF, default OSPF network type will be broadcast. Let me check. Run interface Ethernet 0. Route OSPF 1 network 10.1.100 error 0. Okay. Show IP OSPF interface brief. You can see Ethernet interface enable OSPF and show IP OSPF interface brief Ethernet. You will see the OSPF network type is broadcast. Right? Is broadcast. Okay, go on. The hello and data interval default value is 1040. 1040. Will we choose DR or NVIDIA? Yes. Let me check. Show IP was neighbor. You will be no neighbor. Here, state DR and BDR. Where show IP OSPF interface brief. You can see Ethernet interface state is DR. Show IP OSPF interface designated router. You can see on broadcast network type will be choose DR and BDR. What is DR and BDR? What is DR and BDR? Actually, you can see, you can imagine. Imagination. Okay. In multi-access network, if have multiple router on this link, so if I send a message, same message to everyone, we need to send 1 time, 2 time, 3 time, 3 time. If the router more, the send must more. Send times must more. So we want to have a method can decrease this process. So we choose a DR. We choose this router is DR design router, like a load, or villager head. So we can send information to DR. Later, he collect information and send back. So we can receive all information and less process, right? Okay. So on broadcast link, we need to elect DR and BDR. How to elect DR and BDR? We can modify the topology is like this: R1, R2, R3, R4. On same Ethernet link. Okay. On same Ethernet link. How to elect the DR and the BDR? Let me see. Let's see the rule. 3 process. First of all, we need to choose priority. Router priority. Where is router priority? See the hello. Here is router priority. He use at bits. So the priority range is 0 to 255. Default priority is 1. Default priority is 1. Here is priority. Here is priority 1. Higher will be preferred. If priority is 0, does not participate DR and BDR election. This is priority. The second choose parameters is route ID. Here, the second parameters choose is route ID. Choose big one, like privacy. Actually, in layer 3 protocol, privacy almost choose bigger, choose higher privacy. ORITY choose bigger. In layer 2 protocol, the privacy choose smaller. So you can memory it. Layer 3 protocol choose bigger, and layer 2 choose smaller. Okay. The third one is wait time. The third one is wait time. Where is wait time? Let's see. Hello, Dad. Wait. Wait time equal daytime. Equal daytime. If wait time expired, no one challenging my DR role, so I am DR. Okay. And DR, BDR, the role can't preempt. If network mask is different, can't choose DR and BDR. Can't choose. Let me start a lab and prove it. Before the lab, let me give you an example of DR and BDR. This is Chinese joke. You can listen it. The choice DR and BDR is similar to the let me inclusion movement. DR and BDR is similar. Inclusion movement. One, I look at a piece of land, like a multi-access link. I declare that I am the owner of this land. If no one challenges me for a while, then I become a legend. If no one challenges me, I am illegitimate load. This is wait time. In wait time, when I enable OSPF, ABLE, OSPF, I will be wait time 40 seconds. If in 40 seconds no one challenges me, I will be the DR. One in the wait time, someone challenges me. The R2 enable OSPF. Then we compare our ability. Who is powerful? Who is the load of the land? If the privacy is the same, then whose route ID is bigger? Who is the load? Right? If in this time the other router challenge me, so we need to compare privacy first, then compare route ID. Okay. When the DR and BDR is elected, then come a stronger person. DR privacy 100, BDR privacy 2 or 1 or 1. Now, one stronger person, R3, his privacy is 255. Stronger, privacy higher. Who can steer the role of the load? No. Why not? Because although you are more powerful, but I have not met Miss Meg as a load. Why do I have to give up? I must also as a load, as a DR. This means if DR and BDR elected, so can't be preempted. Can't be preempted. After the DR fails, the BDR take over the work of the DR, and then in the other, like villager, elect a BDR. Because when the load disappeared, one deputy load takes over the work of the load. Because the business is more scared, and then choose a stronger person. He have higher privacy as a deputy load. This means DR fair, BDR take DR role and choose a new BDR. Right? Okay. DR BDR establish full agency to everyone. Between the other will be established two-way stage. One can't choose DR, so neighbor will be stuck in two-way state. Let me practice a lab, do a lab, and prove it. In practice in lab, do someone got this result? I configure full router in enable OSPF on same link. Every time R1 is DR, R2 is BDR, R3 and R4 is the other. Anyone to meet these issues, problems? Actually, R1 route ID is 1.1, R2 is 2.2, R3 is 3.3, 4 is 4.4. In normally a process, R4 should be DR, R3 should be BDR. R1 and R2 is DR other. But in some practice, in some lab, you will be see every time R1 is DR, R2 is BDR. Why? Why? Because your configuration, your type is very slow. Will be met this issues. Okay, let me prove it. R1 and R2 shutdown interface. Shutdown interface. Okay. R2 shutdown interface. R3 10.1 103. Okay. 10.104. Okay. Show run section IO delete this command. OSPF 1. No. Section IO. Okay. Okay. R3 router OSPF 1 route ID 3.3. Router OSPF 1 4.4. Okay. Now we check it. When I enable OSPF on Ethernet interface. Interface Ethernet IP OSPF 1 area 0. No shutdown. Show IP OSPF interface is net. You will be see. Now choose DR and BDR. Here, wait time before designed router selection is 38 seconds because the wait time is 40. You show interface. You show interface. Okay. If wait time expired, now I am the DR. Now I am DR. Before this time, no DR and BDR choose. So if wait time expired, now I'm the DR. Another router enable OSPF. It will be accept me is a load, is a DR. Okay, let me check. Let me try. No shutdown. IP OSPF 1 error 0. Now you show IP OSPF neighbor. You will be see R1 is DR, R2 is BDR. Okay. Show IP OSPF neighbor. Interface is net. Choose designed router, but R1 actually is wait time. Is wait time. I1 interface net. Okay. Show IP OSPF neighbor. Wait 40 minutes. 40 minutes expired. Show IP OSPF neighbor. Oh, why not establish neighbor? The network mask is 24. 25. Okay. We need try again. IP OSPF 1 error 0. No. R1 notify the network mask to 24. Show IP OSPF interface is net. If you change network mask, the choose the designated router selection, where the process will be restart. So, why when you configure OSPF on Ethernet, every time R1 is DR, R2 is BDR? Why? Because your configuration is very slow. Your configuration, the second router is outside the 40 minutes, not minutes, 40 seconds. So R1 is a DR. R1 is DR. Okay, the wait time is expired. R2. Now we enable OSPF. You can see OSPF neighbor established very quickly. I think show IP OSPF interface neighbor very quickly. Who is DR? R1 is DR. R1 is DR, R2 is BDR. Here the DR means this router is DR, your R1 is DR. Now R2 is BDR. Where is R2? Show IP OSPF interface is net. You can see R2 state is BDR. R2 state is BDR, right? R1 is DR. Show IP OSPF neighbor. On R1 you can see R2 is BDR. R2 is BDR. Okay. Show IP OSPF neighbor. Okay. Go on. Now DR and BDR is elected. We use wait time. If wait time expired, before wait time expired, no one challenged me. So I am the load of the land, right? Okay. Now you can configure R3 is net IP OSPF privacy. The default privacy is 1. I'm configure privacy is 100. IP OSPF 1 L0. R4 IP OSPF privacy 255, the biggest one value. IP OSPF 1 L0. Okay. Now you will be see show IP OSPF neighbor. Show IP OSPF neighbor. You can see the DR is R1, the BDR is R2, right? The R3 is the other. In a multi-access link, just one DR is loaded, just one BDR deputy load. Others are villager. The other. Everyone with DR and BDR establish agency, full agency. Between the other, establish two-way neighbor state, two-way state. Okay. Now, R4, this router, the privacy is 255. R3 is 100. R2 and R1 is 1. Why not select privacy higher? Why R1 is DR? Because wait time. Because in wait time, no one challenging R1. Right? Okay. Now, if DR fails, the BDR takes over the work of DR. If R1 disappeared, R2 will be DR. R2 will be DR. And in the other, R1, R3, R4. This is DR. This is BDR. If R1 clear IP OSPF process, clear, then DR disappeared. The R2 will be changed to DR, takes over the role of the DR. The R3 and R4 is the other. Is the other. In the other, R1, R3, R4 will be choose a new BDR. New BDR. Let me try. R1 clear IP OSPF process. Why? Okay. show IP OSPF neighbor. Show IP OSPF neighbor. Wait some time. Okay, you can see who is DR. R2 is DR. Why? Because before R2 is BDR, so takes over the DR work. R3, R4, and me choose priority first. R4 priority is 255, so he will be elected BDR. Right? This is simple. This is simple. So, so this is the process of the DR and BDR selection process. Okay. In some time, you configure multi-access link enable OSPF will be long time. Why long time? Because your type is very fast. Every router must be wait 40 seconds. You can see it. Okay. IP was a 1 error 0 no. IP was a 1 error 0 no. No IP was a 1 error 0. IP OSPF 1 error 0 no. Okay. Show IP of the neighbor. Interface IP OSPF 1 error 0. Show IP OSPF interface Ethernet. You will be wait 40 seconds. In 40 seconds, if R2 configuration, show again 24 seconds. If in 40 seconds R2 configure finished error 0, because R2 route ID higher than R1, so R2 will be choose the DR. So R2 need wait 40 seconds. 40 seconds. Right? And in R2 40 seconds, R3 configuration done. R3 priority is 100 higher than R2. So R3 will be elected the DR. So R3 will be wait 40 seconds. In this time, R4 configuration. R4 configuration. Show IP OSPF neighbor. R4 priority is 255, so R4 need to wait 40 seconds. So if lots of router on a link, you configure version every route. If you type very fast, you must be wait every 40 seconds plus some time, plus some time. So the Ethernet established neighbor will be long time. Must be the highest router. Wait 40 seconds, and the OSPF neighbor will be established down, right? Established down. This is the DR and BDR issues. Okay. If count elected DR and BDR, all device will be stuck in two-way state. How count elected DR and BDR. The privacy is 0. 1 privacy 0, privacy 0. IP OSPF privacy 0. Privacy 0 means not statistical DR and BDR selection. So all devices are the other. The other between the other will be established two-way state. So if you see two-way state all the time, means count selection, the DR and BDR. But you must know point-to-point interface not selected DR and BDR. Just the multi-access interface, right? This is layer 3. This is layer 3 OSPF network type, not layer 2 link type. You can modify link type. No. You can't modify link type. Like Ethernet is multi-access link. The serial interface is point-to-point link. You can't modify the link type, but you can modify OSPF network type on link, like serial interface. You can IP OSPF network broadcast, IP OSPF network broadcast. The link type is point-to-point, but OSPF network type we can modify to broadcast, right? Okay. This is link type and OSPF network type are different. Okay. This is broadcast. Must be elect DR and BDR. Can't generate the host routes. Not. You can see show IP route. I modify 1. IP OSPF privacy 245. Show IP OSPF neighbor. Will be 4. DR and BDR will be establish agency to everyone. Okay. Show IP OSPF neighbor. Okay. The DR and BDR work. This is village. DR and BDR here. Here is the other. DR and BDR belongs to 224.0.0.6. Our village is 224.0.0.5. So the packet sent, the other sent to .6, and DR and BDR sent to the other to 0.5. 0.5. Okay. This is the packet sent, the multicast address. Okay. Non-broadcast NBMA we not discuss because frame relay is removed from routing and switching exam. Multi-point, we can discuss one. We can discuss. Okay. Now you see routes. Now you see routes. R2 and R3 not have. Go back. IPOS1 arrow 0. Go back 0 3.3. IPOS1 arrow 0. R4 go back 0. IPOS1 arrow 0. Okay. Now we see the routes. R1, the next hop is 0.1. R2 next hop is 0.2. R3 next hop is 0.3. So the broadcast link like this topology. R1, then R3 routes. The next hop is R3. The R1, then R4 or R6 routes. The next hop is R6 or R4, right? Like this topology. The point to multi-point, like this topology. If I modify network type to P2 multi-point, here will be R3 and R4. R3 and R4 routes. If you can see the one, R3 check R4 routes. The next hop is R1. Now let me think. Maybe can't do this. Can't do this. Why can't do this? Because this is Ethernet is broadcast BMA network. If you modify the network type to P2MP, then they will be established neighbor where to everyone, right? Where to everyone. So you can use neighbor broadcast. Use this type test. Can use this type test. Okay, we use this type test. R1 is net IP OSPF network P2 multi-point non-broadcast. R2 same IP OSPF network point-to multi-point non-broadcast. IP OSPF network P2 multi-point non-broadcast. IP OSPF network P2 multi-point non-broadcast. Okay. So OSPF neighbor now. OSPF neighbor now. When you need establish OSPF neighbor, non-broadcast must manually establish neighbor. Must manually establish neighbor. Means you need type neighbor command. Okay. Route OSPF1 neighbor 10.1.102 neighbor 10.1.103 10.1.104. Okay. Show IP OSPF neighbor. Wait. Maybe you can. Can't? Oh my god. Show 4. Okay. Show IP OSPF neighbor. if you I use point to multi-point non-broadcast, you must be type neighbor command. If you use point to multi-point, you not use you not need use a neighbor, but every router will be established neighbor agency. So in this topology, R2 show IP route, you will be see R1 1.1 routes next hop .1, 3.1, 4.1. So point to multi-point topology like this, right? Like this. This is broadcast or NBMA. This is P2MP. P2MP, the spoke. This is harp. This is spoke. Spoke, then another spoke routes. The next hop will be point to hub. The broadcast or NBMA, the spoke, then another spoke routes. The next hop will point to another spoke, right? So this is different topology. Okay, the network type is finished. Now we put a mission. I ask a mission. You can build a table like this. P2P broadcast, P2MP, P2P broadcast, and P2MP. Okay. Now you need P2P, and P2P can establish neighbor or not. Yes, you are assigned correct here. If not establish a neighbor, you assigned, you note wrong here. The roots alone correct or not here. Here is roots. Here is neighbor. Okay. P2P and broadcast can establish neighbor or not. The roots then have problem or not. You build a table like this. P2MP, the time, the hello and data interval. So IP OSPF interface is net. You can see P2M multipoint hello and data interval is 30 and 120 is 120. So here 30 120 30 120 right? So if you use P2P and P2MP establish neighbor, you must change hello and data interval same on both sides. Then you can test P2P and P2MP can establish neighbor or not, right? Neighbor roots have problem or not. Okay, this is the homework. Okay, now today the class is over. The OSPF establish neighbor is done. Next time we will be discuss the LSA and SPF exam. Okay. Today is over. Any questions?
Thank you for watching. Visit our website below.